Hello everyone, this is Aditya and today we study the proof of Milne Thomson method. I have already made a one shot on complex sciences for B.Tech and B.Sc. You can check out that video. And before that, please do like, share, subscribe my channel also. And now let's start with this video. So we all know that Milne Thomson method is valid for harmonic functions. So suppose f of z is an analytic function, right? And it is an harmonic function also. So we know that when we are using Milne Thomson method, we set ux, that is del u by del x, as phi 1 of z comma 0 and uy as del u by del y is equal to phi 2 of z comma 0. Then we say that f at z is equal to the integral in complex plane phi 1 of z comma 0 minus I times phi 2 of z comma 0 dz plus an arbitrary constant. So this is a statement, and of course you can use the same method and you can just solve for the case in Vx and Vy, right? Okay, because we know the relation that Vy is equal to Vx and Vx is equal to negative Uy, correct? So you can use this relation and you can formulate this in terms of V also, right? In Vx and Vy. So now let's study its proof, okay? So we all know that f of z can be written as u plus iv, right? Now we all know that u is equal to u x comma y, right? Basically u is this value, it is equivalent to saying this, and v is basically v of x comma y, correct? Okay, now we know that z is a complex number, right? So it can be written as z is equal to x plus iy, right? Okay, hence x is equal to, and what is z bar? It is equal to x minus iy. So let's solve for x and y in terms of z and z bar, okay? So we will have z plus z bar by 2 is equal to x. Similarly, when you subtract it, you will get y is equal to z minus z bar by 2i, okay? So now just substitute this value over here. So you have f at z is equal to the quantity u of what is x, z plus z bar by 2 comma z minus z bar by 2 I plus I times v z plus z bar by 2 z minus z bar by 2 I, right? Okay, we can set z is equal to z bar. So f at z is equal to u of z, what is z minus z bar? It is equal to 0 plus iv z comma 0. So we have this relation now, okay? So now we will be using this one to come to this conclusion. Let's erase this and let's discuss it. So we had got the expression as f at z is equal to u of z comma 0 plus I times v z comma 0, correct? Now from the Cauchy-Riemann equations we can say that, but before that we have to differentiate. So we have f dash of z is equal to, let's differentiate it with respect to x, right? So we have u x z comma 0 plus I v x z comma 0, correct? Now notice one thing. It was this expression fx is equal to f dash of z. What I have done over here is that I should have written it as fx, but they both are equal. Why they both are equal? Because we had proved. You can check out that one shot on complex analysis which I have made in that the derivation of Cauchy Riemann equations. I had already derived this thing, so you can check out that. So we have this expression. Now from the Cauchy Riemann equations we have vx is equal to negative uy, correct? So you have it equal to ux z comma 0 plus I times negative uy, right? So it is equal to ux z comma 0 minus I times uy, right? So f dash z is equal to this expression, right? So from this you can say that f at z is equal to the integral in the complex plane. What is ux? It can be written as del u by del x minus I times del u by del y evaluated at z comma 0 dz, right? So we can basically say from here that del u by del x, if we set it equal to phi 1 of z comma 0 and we set del u by del y as phi 2 of z comma 0, so from this we can get that f at z is equal to integral in the complex plane phi 1 z comma 0 minus I times phi 2 z comma 0 dz, correct? And if you want the expression in terms of v, you can just set ux is equal to ux is equal to vy, and uy is equal to negative vx, and then you will get the similar result in case of v also, right? So this is the basic proof of Milne Thomson method. If you have any doubt, you can just ask in the comment section. And I know that you will get doubt in that expression, which I'd assume that z is equal to z bar. So you can think on it, and if you get any doubt, you can just ask me. I will try to explain it properly, okay? So if you enjoyed this video, then please do like, share, subscribe my channel, and please support this video. Bye bye, take care.